Good morning, everyone. Let me share my presentation materials. So my talk today is a comparison of DeepLab pyramidine parsing net and UNet models for semantic segmentation using satellite image. As a brief introduction, my name's Yaya Heryadi. I'm a lecturer and researcher in BINUS Doctor of Computer Science program, Bina Nusantara University. Currently, BINUS University has several campuses in many locations, including Greater Jakarta, Bekasi, Bandung, and Malang. Semantic segmentation is a process of assigning semantic label or object classes to each pixel. Okay. Many studies suggested that there is no single semantic segmentation model that can achieve the highest performance for every data set. So this became an opportunity to explore several models in order to find out what is the best performing models for particular input data. The second basic concept is machine learning. Machine learning is computational method for improving performance by mechanizing the acquisition of knowledge from experience. Okay, this is the definitions of machine learning proposed by Langley and Simon in 1995. Another definition of machine learning proposed by Michel in 1997, which is defined as an algorithm that has the ability to learn from experience with respect to some class of text and performance measure if each performance of text in T as measured by P improve with experience E. So in the simple word, machine learning is a set of algorithms that can learn from input data without explicitly programmed to do so. Deep learning is a subset of machine learning which can be defined by Francois as a new take on learning representation from data that puts an emphasis on learning successive layer of increasingly meaningful representation. Semantic segmentation is an important problem to be solved because it can simplify image representation into a form that is easier to analyze or interpret. Okay, and semantic segmentation is also a method which can be used to generate land use land cover classification from remote sensing image. In addition, a semantic segmentation method can also be used to recognize land use and land cover change in particular area by using remote sensing image as an input. Two main factors that contribute to the advent of semantic segmentation method. First of all, is wide availability of satellite imagery and the advent of deep learning technology. In the past 10 years had made it possible to improve semantic segmentation tests. However, satellite image-based semantic segmentation is not easy task. Okay, this problem has many challenges, including high object complexity, need to be segmented in the image, cloud partial occlusion, and most importantly, if we use satellite image as an input, the satellite image has a large image size which cannot fit directly into a computer memory. So we have to use some technique to split the whole image into some patches even though this kind of technique has also disadvantages because it can hinder accuracy of the image segmentation result. Research objective of this study is to compare performance of three deep learning models, namely DeepLab, Pyramid Scene Parsing Net, and UNet models. And in this research, we test each of those models to solve binary classification problem, which basically classify a pixel of satellite image into PD field and non-PD field classes. Semantic segmentation from pattern recognition perspective can be formulated as a classification problem. So here the input data set is a set of label of pixel and class of that label. Okay, in this study we only use two class of pixel label, which is PD field and non-PD field, and then training semantic segmentation model is basically process to obtain the most optimum models, okay, to map data into label, okay, from the hypothesis space of the models by using optimization technique. So in this process, we use cross entropy as objective function, which was minimized using Adam algorithm as optimization algorithm in order to obtain the most optimum model parameters. So as I said before, that the semantic segmentation is basically a classification problem. So we use here supervised learning technique to train segmentation models based on deep learning algorithm. In this study, we explore three deep learning models, namely UNet, PSPNet, and DeepLab. We train separately using the same optimization algorithm, which is Adam, using weight decay, and optimization is used cross entropy as objective function, and performance metrics of this study is using accuracy. So this is the input data, which basically an image from spot 6 satellite imagery from Pangku area Kapuas district in Central Kalimantan province. After we augment the raw data set, and we finally have 27,170 ground truth patches with size 256 times 256 and 3 pixel. And in this training, we split the patches randomly into 80% for training data set and 80% for validation data set. This is locations of the object study in Central Kalimantan. This data has been facilitated by Badan Informasi Geospasial from 2015 observation. We explore three models. First of all is UNet, and PSPNet, and DeepLab. And UNet model is basically a symmetric model, okay, having encoder section and decoder sections. Encoder section is to rediscover the location of the object in the image data, while decoder sections to learn what object are in the image by producing features containing information on the existence of an object. So looking at the model architecture, a UNet model is like big U shape, yeah, of a network. PSPNet is another deep learning model proposed by Zhao et al. In 2017, and the architecture comprises of three big parts of three modules. First of all is a module to generate feature map from input image. This module is built by using convolutional neural network, yeah, as a component. And then pyramid pooling modules. There is a module in the middle to extract different sub-region representation followed by upsampling and concatenation layer to form the final feature representation, which carries both local and global context informations. And finally, convolution layer to generate the final per pixel prediction. So this is the component from which we can see the segmentations from the input image. Finally, DeepLab model is a deep learning model proposed by Chen in 2017, so almost 3 years ago. And in this study, we used the third version, which is during the study is one of the latest DeepLab version model. And basically, the architecture consists of two main parts, which is encoder and decoder. And the main important things in encoder part is Atro's convolution. Is a convolution layer with upsample filters to extract dense feature given object of varying scale. Okay, and finally, Atro's spatial pyramid pooling modules to obtain multi-scale context information from the feature maps. Okay, so those are two modules in the DeepLab models that we explore in this study. From experimentation, we found that first of all, in terms of model parameters, we see that the PSPNet is the model with the largest number of the parameters because it consists of 37 million, UNet 19 million, and DeepLab is 24 million parameters, okay, totally obtainable parameters. But in terms of total models, UNet having the largest number of total model parameters because it has 41 millions, and then followed by PSPNet 38 million parameters, and DeepLab is the least number of model parameter because it consists of only 36. Now, the hypothesis here that we set up is the more model parameters, then the higher accuracy will be. Although we know that the higher parameters in the model will cause the longer training process, yeah, and also the higher number of samples needed for training models. All right, in this study, we predict model parameters with the optimization algorithm, which is ADAM optimization algorithm, adopting weight decay to optimize the objective function, which is cross entropy, and then early stopping is adopted in the training models to avoid overfitting. And very interesting that the model performance from each model, as shown in the slide, that UNet give the best training accuracy. Is it the highest in compared to PSPNet and DeepLab? Okay. Also in terms of average training accuracy and average testing accuracy. And this is the result of the segmentation output from those three models. Okay, and if looking from the training process, we see that the for UNet, it appears that the models has a decreased training loss curve and also validation loss curve. So it shows that the model learn from the dataset quite well. And then from training accuracy curve, it also shows that during training, the UNet models improve the model accuracy gradually. Okay, so as conclusion, this study compared 3 deep learning model for semantic segmentation. The input data for this study is satellite image from Pangko area, Kapuas District of Central Kalimantan Province, which are provided by Badan Informasi Geospasial. And from the experiment, we found that the UNet has the largest number of total and non-trainable model parameters, followed by PSPNet and DeepLab. And interestingly, UNet also achieved the best performance, followed by DeepLab and PSP model. This study demonstrates that the proposed model offers a promising approach for semantic segmentation model using satellite image that can be applied to wider multi-classification problem. And the next study that we plan to do is to use the model for further land use and land cover classification. Okay, this is the reference. Thank you. Thank you.